Okay, hey, welcome everybody to the South Shores of Mono Lake. Now, this area where I'm at right now is it's pretty touristy. You know, there's a lot of tourists that come here. There's a parking lot, not even like a quarter mile away, where you could park your car, pay a $3 parking fee, and then come down here and explore. Now, I came to this spot for two reasons. One, I thought it was worth it to show what type of organisms can be found here, and two, this is a spot that does have a lot of people roaming around, and I'm trying to get used to talking around people. Because a lot of the times, I get real nervous. That's why you see me in places where I'm kind of like by myself and everything. So I'm trying to work on that. You know what I mean? Anyway, so I'm not too far from the shore, just a couple of yards, but you can see around me we got these nice natural geologic formations known as tufas. And I think they're called tufas because they're associated with the volcanic tuff that's in this area. Like I mentioned, like the Eastern Sierras are very geologically active. Actually, there in the background, we have a few volcanoes that have erupted. I don't even know how far those erupted. But yeah, there's volcanoes around here, a lot of volcanic activity. Mono Lake itself is actually a product of volcanic activity. That piece of land out there that you can see, that's actually an island. And that's an island that rose up above the surface of the water not too long ago. I want to say a couple hundred years ago, that's when it happened. But anyway, back to these tufa structures. So these tufa structures are essentially kind of like a fossilized or ancient spring system. So back in the day, thousands, hundreds of thousands of years, when you had a lot of glacial activity over here, so that ice would melt and a lot of that water would percolate or sink into the soil and basically go through layers of rock and pop back out in this basin. And as they pop back out, they're carrying with it a lot of minerals, a lot of salts, but a lot of minerals. And those minerals, as it pops out of the ground, would accumulate into these spire-like structures known as tufas. As a matter of fact, there are still active tufas still doing their tufa thing underneath the water. The reason why these aren't active anymore is because this lake was like drained in like the 70s or 80s and everything in order to provide water for Los Angeles. Yeah, these were actually underwater centuries ago. But now, since a lot of water has been drawn away from this lake basin, these have become inactive. There's not enough water pressure for water to actually be pumping out of these. But underneath the surface of the water, apparently there's plenty of tufas still doing the tufa thing, spewing out water and precipitating that calcium carbonate in order to make newer tufa towers. So as far as the vegetation goes, you can see it's pretty green here, even though, we're at the end of the summer and everything. We have two dominant shrub species, from what I can tell, only two dominant shrub species. And one of them is this one right here, which I've shown you before, Ericameria nauseosum, Asteraceae family. Pretty much the only thing blooming right now. The other one is this right here. Ow, damn, I keep forgetting these things have spines. Anyway, so this is Sarcobatus vermiculatus in the Sarcobataceae family, which is a fairly recent, a new family. This used to be in the Chenopodiaceae, along with all the other salt bushes and everything. But I guess it has distinct morphological and even genetic features that warrant it to be in its own family, a family of its own. Alkaline tolerant plant, so it tolerates basic soils. And then down in the understory, we have this one right here. This is Distichlis spicata, also known as salt grass, and this is a very widely distributed native grass here in California. Can be found in the deserts, can be found near coastal estuaries and everything, and pretty much mountains, basins, chaparral, coastal sage scrub, wetlands and everything. This very prominent species of grass. And this species is pretty much the only thing I'm seeing here in the understory and everything, which is kind of interesting because, even though we have like this luscious green stuff, we only have two prominent shrub species and one prominent grass species. And that might be an artifact of the quality of this lake, the water quality of this lake, which influences the soils, obviously, when the soils influence the plant community that can be found here. Is that an active tufa? It's bubbling. The ranger did say that there might be some active tufas, and if you see some bubbling, that's probably what it is. There's another one over there that seems to be doing the same behavior. I don't know if that's bubbling or if it's just because of the waves hitting it and because that rock is so porous, it's just carrying air with it and producing bubbles. But then I don't know, it looks like it's actually bubbling, like water is actually coming out of that thing. Any Mono Lake experts, let me know if this is legit or not. Anyway, so here at the shoreline now, and like I said, Mono Lake is a highly alkaline lake, highly basic, high up on the pH scale. It's actually around pH 9.8, which is it's pretty basic and everything. Like if you touch the water, it feels a little greasy, feels a little slimy and everything, and it's got a little bit of a smell. Actually, a lot of bit of a smell, but it's also known as something called an endoheric basin, which is basically a basin where water flows in and nothing flows out. And because it's an endoheric basin, all the water that flows into here, all it can do is just evaporate and leave behind all the salts and minerals that were carried with it as it entered this basin. And all those salts made it basic like this, giving it its high pH. Very specific conditions for very specific forms of life. You know, forms of life that will exploit this current environmental condition right now. Okay, so now bear with me, imagination time, okay? So now imagine 100 million years ago, before these mountains were here, at least the closer mountains weren't here, and before this basin was here, all this was basically within the confines of an inland sea. So this area, like way before it was even a lake, might have hosted, you know, ancient creatures here as well. Ancient creatures from whence when this was an inland sea. And now because of its conditions, because of its highly basic, highly saline too, these extreme conditions, because of that, there are very few species that live here. Like no fish can live here. It's way too basic for any fish or any aquatic vertebrate for that matter. Like you don't really see frogs here too either. This water is just way too toxic for them. Way too toxic to osmoregulate, obviously. However, there is one species here in which its lineage has almost remained virtually unchanged since hundreds of millions of years ago, before this lake was here, that now calls this lake home, or still calls this lake home. And unsurprisingly, it's an arthropod. And I got my dip net here, so let's try to catch some and show it to you. Okay, so just gonna skim a little bit. Skim a little bit. I'm trying not to pick up these dark things. I'm just skimming the water. And it looks like we got a bunch. Okay, and there we have it. Phylum Arthropoda, class Branchiopoda, order Anastraca, family Artemisidae, genus and species Artemia monica, endemic to this lake system out here. Dang, I didn't realize how many dead ones I picked up. That's crazy. So common names of these things are called fairy shrimp. But yeah, oh look, that one's trying to mate. Oh, he got her. He got her. He's trying to mate with her. So there we have a male grasping onto a female. So it's a crustacean. It's technically considered a crustacean, even though their lineage is actually I think it's closer related to insects than other crustaceans. But they're considered crustaceans, I think, you know, at least morphologically, because they have two pairs of antennae, in which insects only have one. And within the case of anastracans or fairy shrimp, they use that antennae, at least males use that antennae, to grasp onto females. So those antennae have basically evolved into these clasper-like structures on their head to grasp on the females and basically force mate with them, I think. So there we have a female that is gravid. She's got a couple of eggs in her egg sac right there. Okay, there's a male with those enlarged second pair of antennae. So yeah, fairy shrimp, anostracans, you know, these have been around for hundreds of millions of years. You know, they predate insects. They predate most modern crustaceans. And it's pretty crazy to know that there's one single species that is endemic to this area right here, to this lake system. So if you're wondering what they're eating, well, they're likely eating microscopic organisms, probably microscopic algae particles. There's plenty of that in this lake. And also possibly fungal particles that have blown into this lake system, like, for example, fungal spores and everything like that. And when it comes to the nostricans, I mean, this one is evolved to live in this lake system, but there are many other species examples that live in vernal pools or pool systems that dry up like every year. As a matter of fact, sometimes those pool systems can remain dry for centuries. Yet the eggs that are produced, like that female has right there, in other species, those eggs can remain dry for hundreds of years until the next rainfall comes and stimulates them, activates them to hatch. But I don't think that's what's happening here in this system. I think those eggs might just be hatching like straight out, because I can't imagine the eggs like landing up on shore and then not being eaten by the next arthropod that we're going to talk about. But yeah, Artemia monica, celebrity species out here in Mono Lake. Okay, ladies and gentlemen, there we have our second arthropod showcase species here. Here we have phylum Arthropoda, class Insecta, order Diptera, family Ephedridae, genus and species Ephedra hyans, aka the alkali fly. And you can see just how many there are here. I mean, it's an insect. Insects are the most successful animals that have ever existed on planet Earth. There's no wonder it's basically a no-brainer why they're doing so well here. And from an entomologist point of view, it's kind of no surprise that it's an ephedrid that became so successful here. One of the very few insect species that can actually exploit the resources from this very alkaline, very salty lake system. Many species within the ephedridae are, well, the common name for ephedrids are shore flies, essentially. So there are many ephedrids that can be found along the margins, along the ecotone, essentially, from aquatic systems. Some of them can even be found in sewers and septic systems and everything like that. So they've adapted to that type of ecological niche where the water basically meets the land. And a lot of times when the water meets the land, you have a lot of decay. You know, there's a lot of rack, a lot of you know, you can see like these pieces of wood here that have probably come off from plants that used to be there, and now they're decaying, and there's algae growing on them, and these species are both eating the decaying plant matter and the algae that grows in. As a matter of fact, a lot of the hairs and bristles that they have on their body are able to trap air bubbles, and they actually go fully submersible underneath the water and graze on that algae. And in doing so, they will lay their eggs within that algae. Those eggs will hatch. Those larvae, aka maggots, will grow and develop eating the algae and eventually emerge as an adult fly like this. So you imagine with all this biomass, this species itself becomes a resource for other species, particularly birds. And one of those bird species is right in front of me, right there. And we got a perfect example of a male and female. Anyway, both of these are Euphagus cyanocephalus, otherwise known as the Brewer's blackbird. I'm not going to say too much about these because these can be found everywhere. You know, they can be found like in parking lots and stuff like that. But the point is to show you that look at them, just trying to go after the flies and the fly larvae. These flies provide a very highly nutritional, highly protein-packed food source for many bird species, and Euphagus cyanocephalus being one of them. Okay, ecological recap. So we have an endoheric basin here, which supports a lake that's highly alkaline, highly saline, which basically restricts the amount of species that actually can survive in this water. Basically leaving what we just saw earlier to be the dominant species here, Artemia monica, and that's an animal, so it's going to be producing nitrogen, and algae is going to be taking advantage of that nitrogen, using it for photosynthesis and everything like that. That algae then becomes a resource for these Ephedra hyans, and the sheer abundance of the ephedra becomes an ample food source for many bird species, such as this Euphagus. There we have another tertiary consumer. That is Larus californicus, the California gull. Which is funny because I think there's more of these. These are more abundant in the middle of the United States than they are actually in California. I rarely see these in California, to be honest. I'm mostly used to seeing Larus occidentalis, the western gull. But you can tell it's a California gull because it's got a little bit of black on its beak. It's like black mixed with red. But there it is, just like trying to pick away at the ephedra. Easy meal. Oh, look, it's picking it off the foam. I wonder if those flies are getting stuck in the foam, making it easier for them to pick off. And you can imagine, like these birds are not even putting a dent in the population of these ephedra. It's just too much of a paradise out here for those little insects. And I guess this is their devil. Yeah, Larus californicus. Getting its nutrient-dense meal out of these ephedra. Oh, and look at what we got there. We got Pandion haliaetus. You mind turning around for me, my dear, so I can see your face? Or, oh yeah, hey, there you go. That's what he thinks about me. This fool is like, show that to your viewers. Oh, and it flies off. See, it's probably because I was talking. Anyway, family Acitripidae, family of hawks and eagles. Oh, there's another one right there. Another nest. Hey, it came back. All right. Very common in the northern hemisphere, at least in North America. I hear in Europe these are endangered. Their numbers aren't really doing too well out there. But yeah, it's a raptor, bird of prey, and a pretty good fish hunter, which begs the question, why does it choose to nest here when there's no fish here? I'm curious about that. There's definitely fish in the rivers and lake systems up there. Maybe this thing will take the journey almost every day to fly to one of those lakes and pull out a fish. Or maybe dead fish will flow into this lake system via the rivers and streams, and it'll just pick those off, like kind of like easy picking, because you know they can't survive in this saline type of environment, so they just die, float to the surface or whatever, and they just pick them off and eat them. I don't know. I'm not sure. Yeah, Pandion haliaetus, the osprey. Man, there's a second nest over here, which is not too surprising, although it is surprising to find two nests in one area like this. I didn't realize that ospreys will nest so closely together like this. But it makes sense why they're using this tufa as nesting sites though, because you know it's safe. It's very safe. Safe from anything that might want to harm it. Well, it's safe from any legal impacts, I should say. You know, there's always the chance that some jackass will come out here and like throw a rock at it. I don't put it past humanity to do stupid stuff like that. All right, it's starting to get a little windy, a little chilly, and those clouds in the background are looking pretty ominous. So I guess this is a good time to sign off and get the heck out of here. Once again, I appreciate you watching my videos. I'm gonna try to come out with more, try to give you some more of that good biologizing content. You know, thank you for watching this video. Hopefully you learned something about some of the organisms that can be found here in the Mono Basin area. You know, we started in the hills way over there, and now we're here at the South Tufa area, which again is a tourist area. You can come here, just pay the $3 parking fee and everything, and you can get a load of this biology all for yourself. So now just remember to keep your decisions scientific, stay away from all the gimmicks. I'm Ichabod Slice. Peace up, peace out, learn something.